We're going to look at a very simple demo app to kind of see how these things work in practice. So we actually looked at taking a CLI app and trying to, convert it to support Universal to see how that would work, given what's in progress today and what's available today. So, right off the bat, you're pretty much getting into ejecting out of the CLI to make this stuff work. So this was actually caused a lot of problems in terms of, there's a lot of Webpack config, a lot of customization and things that make it difficult to take an existing CLI app and get it into, get it to support Universal without really getting into customizing the build process and things like that. So, if that's something, if you're considering Universal and you want to maintain CLI support, I think that's it's still a little bit premature to be going down that road. That said, they're doing work right now. In fact, there was a pull request that was merged like 2 days ago that's starting to get some of these things into the CLI. So it's coming, but at this point, expect that you're going to be, bleeding all over this stuff. So there's also an official example that's supposedly coming that will replace the existing example in the Universal Starter repository. This is still the old one, so if you come across it, it's pretty outdated. So the one that we're going to look at tonight is this NG Universal demo. This is actually a fork from a project that Rob Wormald put together. It actually works if you clone it down and run all the steps. So I think this is probably one of the better models right now, and that's what we'll look at tonight. It's very simple. In fact, it's not even using the pre-boot module at this point, but it does kind of show the concepts. In this particular example, so we kind of glossed over this, but there are many separate use cases, right? So we mentioned like the app shell is one use case, SEO, things like that. So there's a couple different ways that we can actually build an app depending on what your needs are. For example, if you had a very content-heavy site and you wanted to just generate all your static content, that's one possibility. So you generate all your pages and you put that up on the CDN, and that's what users get. Another possibility, and what we'll look at tonight, is actually dynamically rendering. So we're going to replace our static content with an actual server that's running Express, that when we hit our our endpoints that serve our index file, it's going to render our server-side content and send that down. And then there were, in the earlier days of the CLI, there were some mobile options that were geared towards building out progressive web apps and some support for the app shell. Those things kind of went away with the transition from System.js and Broccoli to the Webpack version, but those things hopefully will be coming back soon. So that's another case where maybe we just want to use Universal to render our shell, so that when a user opens the app, they see something. They're not just seeing a white screen. They're actually getting content, and if they're offline, we can cache it. The app will still work. It may not be fully interactive, but at least, we're telling them something. We're giving them a good experience. We're reducing the time to interactive, etc. So let's see. There's also a guide in the official Angular docs. This takes the Tour of Heroes example or tutorial and adds Universal to it. So it's one way to to do this as well. It's still, it's somewhat contrived in the sense that you might not build a production app in this way, but at least you can get some experience setting it up and getting the AOT and the universal build configurations, etc. So it's worth mentioning. It's there if you want to go through that. Okay, so let's take a look at this. Make it bigger so we can read it. So this is it's a super simple app. We basically have two views. So there's a home view, and then we have a lazy loaded module. It's just got some content that we can load on demand, via the Angular router. And then, we have most of the standard things that you would see in a vanilla app if you generated it from the CLI. With the exception that we're managing all of the Webpack config, so we won't get too much into this. Most of this works fairly similar, although we have additional files to build the server bundle. So in this case, we're using Express. It's a very simple Node server, and we're going to use Webpack to compile the server, which is also being written in TypeScript, and generate that bundle as well, in addition to our client assets. In this example, he's split up the Webpack configs, so we've got some common things, and then the various prod. Well, prod doesn't have anything, but our client pieces, which are using the standard ng tools Webpack plugin. So this does all the AOT compilation things like that. So the next thing is we have a couple of entry points. So instead of just having a main, we're actually going to have two entry points, one for the browser and one for the server. There's also this server.aot. This is actually a temporary file that deals with some of the details of including the ng factory module that's generated in the AOT compilation process. This pull request was the one that I mentioned, so this just got merged. It's in the CLI, so you'll be able to. The CLI will be able to handle, basically generating these bundles and the AOT process for all your server, anything that is importing platform server. So this actually goes away now once the next version gets released. That should be a capability. So,
one quick question.
Sure.
I'm not sure you're using import and all the node code. That was
Yeah.
node code.
Yeah. So we're we've got we're building the server output with Webpack. So we're doing the transpilation. It supports, it's set up to support the modules and so forth. Yes, 2015 modules.
I'm just curious if it was translation or if there was like some minimum version of node.
No, it's all being handled through the transpilation. It's actually TypeScript. And there's no requirement to do that. I mean, it's ergonomics. Exactly. So you can write your server in whatever you want. It doesn't need to be Node.js, but that's it's going to require implementing the modules to handle building the output. So those things are coming for other platforms. Node is the one that's going to be supported fairly obviously right now. But if you're using some other server platform, Java or what have you, those will be supported eventually. So let's look at the server entry point. We're importing a bunch of things. Probably the most important thing is our server app module that we'll look at. as well as this, the ng-express engine. So this is the Express module that the Angular Universal team built, and that would still be probably the module that you'd be using today for a Node.js platform. And what that's going to do is, that's doing the heavy lifting of taking the entry, taking our app module, and rendering our output based on the parameters of the request. So we're setting up an HTML engine that's going to use that Express engine plugin, and then we're setting up set up the view engine to use the HTML engine that we set up. So basically, whenever we render out our index page.
I see the importing from Angular versus I thought you mentioned that would be like inside Angular, so what would like Angular slash universal so we don't take inside the CLI?
So the Express engine is not part of core. These platform server pieces are what have been migrated into Angular core. So these, and I don't know, to be honest, I don't know what the plan is for the rendering engines, whether or not those are intended to be, will ever make it into sort of the Angular core or not. There's anyone who wants to build an engine for any platform could do so. So, Angular is providing the pieces to handle within the Angular app itself, and then the actual rendering, how we handle that from a server side perspective and the routing and so forth to get it into those pieces would be a separate external module. So again, some basic Express setup things. We're going to serve any static assets from our distributable directory. We set up, in this particular example, the routes are sort of statically configured as far as determining which URLs will get routed to the Express engine to render the app. So in this case, we just have two routes, the home root URL and the lazy URL. So let me go ahead and actually run the app quickly so we can just kind of see what it looks like. Building. All right. So this is our app. Pretty exciting. So we've got to get this out of full screen too, so we can see the address bar. So two views. If I click on this one, you actually look at the network traffic. You can go back and see that we're indeed lazy loading this bundle. So this is the chunk for our lazy load. But if we go and if we actually look at the page source, we can see that yes, that is tiny. So if we go back and look at our index file, it's the basic scaffolding that we'd expect to see. We have a root element for our app, and that's it. So in a normal Angular app, that's our container for all of our DOM content. And if you take a vanilla Angular app and look at the page source, this is what you can see, essentially. But in this case, we actually see that we've got all of our DOM content rendered into that document, and that's what Universal is doing. That's what we're doing on the server. So we're taking our app, put it through the Universal pipeline, and basically generate a string, and then we can render that string into our index document, and that's what comes back in the request response. So what that means is, I can go in here and disable. I should be able to disable JavaScript and still be able to load this thing, right? And I can click on the lazy link and
When you click on the lazy link here, you're actually doing the href rather than the router, and it's hitting the server again and then bringing it back.
exactly. So you'll see that I'm actually loading the document. We're not seeing any JavaScript here, right? This is all old school HTML, server-side rendering. So that's great. This is obviously a very, very simple app, and you quickly run into things that complicate this, right? So if you wanted to build out a fully interactive app, and it's got animations and things like that, and you start putting Angular material in here and all that kind of stuff, you'll start to run into issues. So I think the takeaway is there are things that you can do today if you're going to go down this path and you want to be able to support these things. Being aware of those caveats and anticipating those kinds of things will make supporting these kinds of use cases a little easier. So some of the reasons too that you might want to do this is it's less likely today that somebody's going to disable JavaScript, but there are many cases where JavaScript becomes disabled that are out of your control, right? So a mobile user on a train going through a tunnel, is the classic example where they lose that connectivity. You can still serve something up or have something cached. So at least they're getting a message that says, we're offline right now, but it's when you're back online, we'll be able to help you out. Maybe you can do something. There might be some interactivity, where you can cache data locally, and then once you're back online, be able to sync back up and restart the app, sort of asynchronously without them having to do a whole bunch. So anyway, that's the demo. So we'll go back to looking at, how this is enabled. So we have those two routes that we saw, the home and lazy. So when the server, when we route those, we're actually routing those to these handlers. So we're generating a handler for each route. And within that callback function is where we're rendering the index file. And so that's going to pass everything through this HTML engine that we set up. And from there, really, the Express module takes over and does all its thing. So this is, the output of that is to generate that string that gets injected into the HTML document. And then we're just sending back static data, static assets for everything else. There's also this data endpoint that we'll look at that was added to demonstrate some of the things that we have to deal with in terms of what happens when we need to fetch data for our app, and we're fetching that on the server, but we don't want the client to have to go and make another request for that data. We want to have all that data available so that when the app boots, it can just go and do its thing. We don't have to make another HTTP request. So we'll look at that a little bit. Let's see. There's really nothing too special in the browser module. It's the same, Bootstrap process. all of these things can be, optimized for AOT and so forth. So won't go into that too much. But let's look at the server app module. So this is basically on the server. This is going to be our entry point. This is our entry module. And when we run in the client, we have a separate, browser app module, which is fairly straightforward. There's not too much that's different from here, other than this browser module with server transition. So you'll notice that in both of these modules, we're making the same call and assigning an app ID. And the reason for this is that when we render our app into a string, we're providing a DOM and we're shipping that down to the client. And when the app boots, Angular is going to run and generate its own DOM, from the app module. So that process happens again, and then we're going to take that and swap it out. So we need to be able to identify the pieces that are associated with the app. So that's what this app ID does. It allows that transition to occur. Other things that are happening in this module, we're actually so we're providing this Bootstrap function, and we have a custom provider that imports the app Bootstrap listener token. So we want to provide basically our own implementation for this hook. In this example, the reason for this is to set up the state transfer. So I mentioned, in an app that is fetching data, where we need data to render the app, we'll fetch that data during the request. So we can go out and get whatever data that particular handler needs, and then we want to render that data into the document and pass it down so that when the app boots, it has it. So this is one way of doing that. And this is, as Kevin mentioned, is one of those things that the Angular team is working on, building some standard modules to be able to do this. So you don't have to write this code. But we don't have it today. So we'll look at how that works. It's fairly simple. Let's see, anything else here? So I think that's mostly, I think that covers the server app module. So let's look at, we have this other directory that has a couple, some of these additional modules. So these are implemented as helpers to deal with some of the things that aren't available yet. Transferring state is one. Another is dealing with handling HTTP requests. So we want to be able to sort of intelligently build the app in a way that we don't have to care whether or not the data is available, if it's already cached, if it came down. The application can simply use this HTTP wrapper and make its request like it normally would. And if we have the data that cached already, then we can simply return that, or we can go and make the asynchronous HTTP calls. So we'll come back to that, but let's look at the transfer state. So this piece is not terribly interesting. It's basically just a key value store for the state itself. So the server transfer state class is the really the meat of this thing. So this is the thing that is going to handle rendering this data into our index file. So if we go back to the server app module, we'll see that once the app is stable, and so we've already bootstrapped. We're waiting for Angular to become stable. The app becomes stable, and at that time, we'll call this inject method on the transfer state instance. And what this is doing is it's going to get a reference to the document. We're also going to take to render the state itself into a JSON string, and that's what we're going to put into the document. So all of these things deal, this part through here deals with setting up the renderer so that we can write that data out into our document. So again, the renderer in this case is really an abstraction so that we don't have to care about where we are, whether or not we're on the server or the client. But we can treat this as we can be agnostic about whether or not we're in a browser and still be able to interact with the document in a way that makes sense as if we were on the browser. And all it's doing is just writing a script tag into the head with that sets the global transfer state property with the data, our state data. So if we go back and look at the example app and the source, we can actually see where this gets written in. So on the server, we're writing this into the document head, and so we'll have what's that called? So we should have a global variable with the transfer state in it. We don't, because we disabled JavaScript. So if we happen to have any data, so in this case on the lazy view there's no data, but we reload this and we'll see that we've actually got an object with that data. So when the application boots, it will be able to pull that without actually having to go and make another request. This is a fairly standard way of doing this. If you've done anything with React and React Universal, generally, it's a similar pattern. So that's one piece. The other piece is dealing with HTTP requests. And this HTTP service, transfer HTTP service, is essentially a wrapper around the Angular HTTP service. And it exposes the same methods, but we wrap all of the calls to this getData method. And this is just basically checking to see if we already have that data cached. So, we can write our code in such a way that we don't have to care whether or not that data is there. Yeah. So this it was written. I didn't write it, but it seems likely. I mean, it's the yeah, this is part of the, so this is the frozen, let me get back to that. So if we go back to, so this demo came from this project, so it's in here. But I think we mentioned, so back in the one of these slides, So this bullet point in particular, providing a standard state transfer module that would also have the HTTP interceptor, or behavior that's similar to if you've used Angular JS, Angular 1x, right? There was this concept of HTTP interceptors. This is roughly analogous to that, right? There's no direct analogy in Angular. The recommended pattern is to compose the provided Angular HTTP service and then wrap those methods to handle fetching from the cache and so forth. So today you would need to build something like this if that's a use case that you need to support. So I won't go through all of this. It's fairly straightforward, but it's basically, if we don't have the data cache locally, we're just going to delegate to whatever the corresponding HTTP method is and actually make the async request to get the data. So that, I think, covers pretty much this demo. It's very simple. We didn't really talk about pre-boot. That's something that is still, right now, is kind of changing. I would be wary of building that into a production app today, but so all of those sort of advanced use cases where you're dealing with rendering a form, for example, and you want to be able to enable the user to start interacting with that form and then have that, all of your values transfer to the model and so forth once the Angular app boots up, would all be handled with the pre-boot. Today would be handled with pre-boot. So, questions? Yeah.
So this is pretty much the only option if you want to try to render Angular up on the server at this point in time, right?
Yeah, so it's, platform server is the thing, and that's, doing a lot of the heavy lifting. It's sort of all the ancillary pieces. Dealing with like third-party JavaScript libraries is a big challenge. So, we've got an app that uses a popular mapping library. We can't render any of that on the server because it very much depends on the viewport, right? So we'd have to deal with, we can render a shell, like we can render the container for the map and things like that maybe. But, it really depends on what your intent is. For, I think, the progressive web app case, supporting the app shell, being able just to have some basic structure there so that, your user thinks that something is happening or they know that, something is coming. So if you want to, like, we see this a lot now, with native apps and mobile web apps where you'll get, say, a list of posts or something, and it will show, just some blank things that look like lines, so you know that the text is coming. And when we talk about performance, it's not just about how quickly the page loads, right? It's how quickly you get something in front of the user and signal to them that something's happening. So your metric of time to interactive, which is really the time that the user can actually start doing something with your app, I think is where Universal is really going to start to become a little more important.
So when you're talking about, like, it's rendering some, I guess, just kind of graphical lines and stuff, is that kind of the stuff I've seen sometimes in the sidebar where it's just like...
Yeah. So, like, even, I may have, like, a Slack channel.
Like a navigation.
Yeah, like, if I reload Slack sometimes, like, I'm getting progress. Like, you see these things on the sidebar. There's nothing there, but I know something's coming. So it's that kind of thing.
From a historical standpoint, if you had a mapping JavaScript thing on a page, you're running most of the page on the server, you would never go rendering the map on the server anyways. That was always kind of a client-side thing, right?
Well,
it's not like you really lost anything, per se.
Yeah, I suppose. Actually, the old mapping apps rendered the maps on the server. That was the early days of MapQuest.
That's true.
So,
I mean, we're talking like a Google Maps embed or something like that, which you've been able to do for years now.
right.
The tiles and stuff are rendered, but I mean, the whole little mapping window where you drag everything around is something that was always done on the client side. So you may have served up a static page that had the JavaScript to load that map,
Right.
and in terms of what we're doing today with Angular Universal, it's pretty much the same thing.
Yeah, maybe. You know, I think where we run into a lot of trouble are, you know, certain graphic heavy types of things. If you're doing like positioning, that depends on the width of the viewport and stuff like that. There might be some complications there, but we'll see how that. The third-party integration part, I think, is still a challenge.
What it comes down to my mind is everything that you could pull off the native element, there needs to be kind of RPC type of connection back to the server, so the server can query those things and do so efficiently, not in a serial fashion, but in a batch fashion. You know, you got RPC, procedure call.
Right.
So it really comes down to it. I mean, if you need to size your viewport, you've got to query that native element and say, how big are you? That information will not exist anywhere else except that thing on the client side. So you have to make the call to the client side to fetch that before you can start the rendering. Take an application like you're doing a ray trace, which might take a long time to compute, but you want to get the frame up and sized correctly so it looks like it, and then you start raster by raster filling it in with ray trace. But you want to get that initial frame up, so that's a universal side thing, but you also need to know back on the client side is you're going to start rendering whatever's going to drop into that frame.
Sure, yeah.
You need to know the dimensions.
Yeah, if you're doing like anything like within a canvas or something like that, I mean, those things are going to happen on the client, and I don't think that's going to change. You know, a lot of
Well, I'm proposing a situation where the computation wouldn't have the resources on a phone to render a ray trace in a tenth of a second or a second, because it would take minutes on that small processors, whereas you could have a cloud of 20 processors out on the server side rendering. So there are situations where you just need to know the dimensions right away, and then off of the server side you render things, and it comes back as a PNG initially, and then the clients have to take over and manipulate it from there.
yeah. So it sounds like you're saying, I mean, you'd have to be able to send that data to the server for your container, right?
Or on the initial connection, those things kind of just get dropped down. Here's your major client array size, things like that.
Sure.
When I say in bulk, I mean it should come down in one message. You shouldn't be back and forth trying communication that slows the data down. You come down in the initial connection.
Yeah, I mean, I'm not sure that I have a clear picture, but we can talk about that after.
Yeah, is there a way to tell it like, hey, server, don't worry about this certain component, the client will take care of that? Like, what's the mechanism there?
Yeah, so that is the so we can interrogate. I don't know where that slide ended up. So is this what you were referring to? So this is where, like, in our code we can bail if we know that we're on the server. You know, I think a lot of the issues, for example, with material, you know, were in things that dealt with like animations and things like that, where the dimensions and the data is coming from the element itself, which we don't have available. So if you're doing pure CSS types of animations and things like that, and responsive design, you know, purely with CSS, then you're good to go. But if you're doing, you know, using JavaScript for your animations and things like that, we don't want any of that to run on the server. And essentially the rule of thumb is don't touch the DOM on the server, you know. So, you know, it's getting those components that were implemented in that way compliant, so that we're not referencing the native element directly. We're going through the abstraction to do that. Yeah.
Do you remember at NCConf, did they mention, and I guess they were using this now, and after you did, and you had to do with this presentation, did you consider using it now as opposed to
So to answer your first question, I'm not aware of any production project that, like, large scale production. I didn't come across anybody at the conference that was using it. So we haven't had any projects where we would recommend, like, today going all in. I think at this point it's more, if you understand, like, if this is something that you want to do, or something that, like, for example, if you're building a content heavy site, it's worth sort of maybe planning around that to be able to add this in when it does stabilize. So if you're supporting link previews and stuff like that, we've done some work with blog types of content management system applications where it would benefit from these things, but might not be fully implementable today.
I was just going to ask if there's any best practice application structures that they've come out with. Like, I look at this and I feel like, having an if statement of, like, hey, put all your client side code here and dump all your server side code here. It's gonna get messy if you have a large scale app. Is there a way that they're managing common functionality, JavaScript versus client side functionality and server side structure wise?
So I'm not aware of anything official, like, official guidelines, but I would recommend taking a look at what material design is doing, what that team is doing. So I think this link to this issue has quite a bit of, fair amount of information. I always look at the Angular source code and their projects first to kind of see what their patterns are, because they're generally, Google generally knows what they're doing, but I don't know.
It could be a little more reactive. It could be like on engine server.
Right. So, these things are being discussed and proposed. So sorting through, all of that stuff is another part of what makes it difficult to implement today. If you're looking at, documentation that was written 3 months ago, it's already, a lot of that stuff's already out of date. So it's very much still in a kind of experimental phase, but the just the fact that we can do it is a big step forward, and it's not unique to Angular. This is also a feature of React as well. So there's some prior art in that area as well. Anything else?